Today we're going to cover Chapter 2, Section 3, and today we're going to analyze graphs of functions. So we're going to be finding the domain, the range from our graph. And remember, your domain are all going to be your x values. And what we're going to do is read our graph from left to right. For the range, it's going to be all the y values, and we're going to read our graph from bottom to top. We're going to be writing our answers in interval notation. So remember, when you have a solid dot or a solid circle there, it'll be a bracket. When it's open dots, it's going to be parentheses for our interval notation. We're also going to be identifying the increasing, decreasing, and constant portion of the graph. And again, we're going to read our graph from left to right. The increasing, decreasing, and constant is going to come from the domain. So think of the increasing as sort of like a positive slope. It's going to be the part of the graph that's going to rise from left to right. The decreasing part will be like a negative slope. It'll fall from left to right. And then the constant is just going to be a horizontal line, a flat line. All of our answers, again, are going to be given in interval notation. Now, for WebAssign, it's not going to want you to put in brackets. So when you're doing the increasing, the decreasing, and the constant on WebAssign, always use parentheses around everything. Okay? Just remember that open dots indicate that where maybe we're going to be looking to see where the graph starts and stops. But again, we're only going to use parentheses. So even if it's a closed dot and in the domain, we're going to put it with a bracket. But when we list it for increasing, decreasing, constant, we're only using parentheses. And that's what WebAssign is going to expect you to enter. So let's go ahead and take a look at some examples. So it wants me to find the domain, the range, where it increases, where it decreases, and if it's constant. Now, it doesn't necessarily have to have all increasing, decreasing, constant. When you're doing this on WebAssign, if it does not have a portion of the graph that is increasing, you're going to type in DNE, does not exist. So anything that does not exist as far as the increasing, decreasing, constant, that's what you'll type in. Now, you will have answers for domain and range. And this one, you do have to use the brackets. All right, so remember, domain is your x values. So what we're going to do is we're going to pretend that we're standing here and we're going to walk along the x-axis. And we're going to look to see what's our first x value that we encounter. The first x value I encounter is right here at -3. And notice it's an open circle. So when I go to write my domain here, I'm going to start, and the first x value I came to was -3. Now I'm only looking at x values. I'm not looking to see how high it goes. Domain is left to right. So then if I keep walking along, I still have x values here, but then I stop here. So then I'm going to put comma 0 with a bracket. Now right here, I have a gap. There aren't any x values. But now when I look up here, I've got an x value. It's right here at 2. Now I need to use the union symbol. So the gap, the red gap, would be where a u goes. And then it starts up again at +2. It's an open circle, so I use a parentheses. Now, don't be misled by this arrow that's on the end here. It looks like it's pointing up, but if you think about it, it's actually pointing up and towards the right because it's sort of curved or slanted outward. So it's actually pointing up towards positive infinity for the y's, but it's also continuing on this way. It's slowly, gradually going out towards the right as well. So it's actually going to keep on going for my x values. So this will continue on to infinity with a parentheses. So that is your domain for that graph. Now what we're going to do is cover the range. The range is from bottom to top. So let me go ahead and erase this blue stuff and start over again. So now what I'm going to do is I'm going to start walking up from the bottom. And I'm going to start walking up. Now my first y value that I encounter is right here at 0. So, and that's got an open circle. So for my range, the first value I come to is 0. And then notice this segment here, it's including all these y values. So I still have y values until I get to here, and then it stops. It's a closed circle, so it gets a bracket. Then I've got a little gap here before the graph takes over with the other piece. So that'll be my u. And then now it's starting up again here, over here at 3, with an open circle. So it's going to be a parentheses. And then again, it keeps on going to infinity, because the line keeps going. And that is your range. And these are y values. Now we have to figure out where the graph is increasing, decreasing, and constant. So let me go ahead and erase some of this stuff. Now, again, if you want to think of the pieces of the graph like slope, that's where you can maybe help to identify where it's positive or negative or constant. So, for example, over here, this piece, it looks like it's a positive slope. It's rising from left to right. So this would be an increasing piece. And I got to write this in interval notation. And then my next piece of my graph is the same thing. It's going upward. So this is also an increasing piece. And it comes from the domain. So now when I write my increasing, it's increasing, and I'm only using parentheses. So it increases on this piece right here from -3 to 0. And then it increases on this piece from 3 to infinity. Or 2 to infinity, sorry. Now, there is no decreasing part to this graph. So for decreasing, you're going to type in DNE on WebAssign, and then the same thing for constant. There are no flat or horizontal lines, so you're going to say DNE. Now, you don't have to put the union symbol in between those increasing intervals there. And again, always parentheses. So basically, all I did was rewrite the domain, but with all parentheses, because the whole part of the graph was just the domain, because both of them were increasing. So again, increasing, decreasing, constant always comes from the domain. Let's try the next one. Now, do not be misled when we go to identify the increasing, decreasing, constant with the arrows. So let's go ahead and set all this up. So domain. So again, I'm walking along this x-axis. And the first thing I encounter as I walk along is this arrow. Now remember, this arrow, it's pointing down to negative infinity for the y's. But it's also slowly creeping outward to the left, also to negative infinity. So it's actually getting wider and wider, and it's actually going this way and this way, because it's getting wider and wider. So my domain here is going to be, first thing I encounter was the arrow pointing to negative infinity. And then as I walk along, this is where it stops, at -2. And it's an open circle, so it's a parentheses. Then I've got the gap, no graph. Then the next place I hit an x value is right here at 1. And it's a closed circle, so it's a bracket. And then my next x value where it stops is at 2, and it's a parentheses. And that's your domain. Now we're going to do the same thing, walking from bottom to top. So for the range, go ahead and erase. Okay, so first thing I'm encountering as I'm walking up here, the first thing I hit is this arrow over here, and it's pointing to negative infinity. Then as I keep walking up here, it stops right here. It's an open circle, so it stops on the 0. Oops, let me change this color. And now I got a gap again. And then my next y value where it starts up again here is at 1. And it's a closed circle, so it's a bracket. And then it keeps on going. And then it stops at +2. And it's an open circle, so it's a parentheses. Now we have to figure out where the graph is increasing, decreasing, constant. So let me write down these 3 words. Increasing, decreasing, and constant. So let me go ahead and erase so I can sort of see what I got here. Now again, don't look at the arrow and think that it's pointing down and think that that first piece is decreasing. So pretend like the arrow isn't on there. And again, just draw over the line and you see how it looks like it's rising from left to right. So this is an increasing piece. Don't look at that arrow. And then this is also an increasing piece. So again, this one's easy. They're both increasing. So just rewrite your domain under the increasing, next to the word increasing. So it's going to increase from negative infinity to -2, and then from 1 to 2. Again, there are no decreasing, and there is no constant piece. Let's do the third one. Again, let me set up all my words here. So I got domain, range, increasing, decreasing, and constant. All right, so for the domain, again, it's your x values. So if you're standing here on the x-axis and you're walking across, the first thing I come to is the arrow. And again, remember this arrow is pointing up to infinity for the y, or for your range. But over here, it's pointing, it's going up and out. So it's actually, the first thing I encounter for my domain is negative infinity. And then as I'm walking along, my next x value is right here at -3. It's an open circle, so it's a parentheses. Then I've got a little gap. And then it takes up again at -2. And it's a closed circle, so it's a bracket. And then it goes along from -2, and then it stops at +1 with an open circle. Then we got a gap again, and then it starts up again at +3, and it's a open circle, so it's a parentheses going to infinity. Because again, this is going up and this arrow and out to the right. So out to the right to infinity and up to infinity. For the range, I'm going to go bottom to top. So as I'm coming along here and I'm walking up, the first thing I encounter is right here at +1. So at 1 with a bracket, because it's a solid line. Now, notice here, I've got a closed circle, an open circle, an open circle. If you've got more than one circle along that Y value, the closed circle overpowers or takes over for the open circles. So that's why it's a bracket. And then you may look at this and think, wait a minute, there's a gap, but there isn't a gap because you have to look left to right. So over here, this one is continuing. So there was no gap here, so this is going straight on up to infinity. So that one took over. So there was no gap because you have to look over here to the right and you see there's still graph there. Now this one, we've actually got something for increasing, decreasing, and constant. It actually has all three things here. Again, do not look at the arrows. They're going to confuse you. So pretend like the arrows aren't on here. So what we're going to do is trace over the line. So this one looks like it's falling. So this one's decreasing. This one's the flat line, it's constant. And then this one's rising from left to right. So that's the increasing piece. So I'm going to take each one of these individual sections of this domain and put it for each one of the increasing, decreasing, constant. So it's increasing over here from 3 to infinity. And again, just use all parentheses. It's decreasing at -infinity to -3. And the constant is from -2 to +1. And these are all X values. Again, don't look at the arrows. They're going to confuse you. Let's try some more. Now, it also wants us to evaluate the function at these given X values. So let's go ahead and evaluate it. So when X equals 0, all I have to do is come down here and see what the Y value is, and the Y value is -4. When my X value is +3, it's right here, so you can see your Y value is 0. So before we had equations and we had to plug in those X values, now we just see where it's hitting the Y-axis. All right, so now let's figure out the domain range increasing, decreasing for this first graph. So domain, again, as you're walking along, the first thing I encounter, my first point is right here at -2. Open circle, so it's a parentheses. Then as I walk along, I still have X values underneath here, and it stops right here at 0 with a closed circle, so it's a bracket. Then I've got a little gap here, so I'm going to union it. It's an open circle, so it'll be a parentheses, and this X value is at 1. And then notice again, it's going up and out, this arrow. So it's going out to infinity and up to infinity. So then parenthesis infinity. For the range, we're going bottom to top. So the first thing I encounter as I'm going up is a point right here at -4. Closed circle, so it's a bracket. Now again, notice as we're going up this thing, you might think, okay, it's still got y values over here, and then this graph over here takes over, and then it keeps going to infinity. So again, you got to look left to right to see if another piece of the graph is taking over, so that you may mistake a gap when there really isn't one. Okay, now we're going to do our increasing, our decreasing, and our constant. I'm just going to put capital I, capital D, capital C. All right, so let me go ahead and get rid of some of this. So again, this piece of the graph looks like it's falling from left to right. So that'll be my decreasing. And then this one, it's going up. So it's the increasing piece. Again, no constant here. So the constant does not exist. The increasing piece is from 1 to infinity. And the decreasing piece is from -2 to 0. And again, always x values. Yes?
So for increasing and decreasing, you ignore the brackets?
Correct. So just use parentheses for increasing, decreasing, constant. Ignore the bracket. All right, the next one is actually a graph of a parabola. The parabola, its domain is always all real numbers. So because if you think about it, this U shape is going to keep getting wider and wider and eventually cover this entire x-axis. So the domain of all parabolas is always all real numbers. So you're going to write it from -infinity to +infinity. Let me also go back and evaluate f of 0. So when x equals 0, I come up here and here's my y value and it's 1. Now let's do the domain. Now the range is not all real numbers for the parabola. We're going to look to see where that vertex is, and that'll be a clue of what our range is. So the range, as I'm walking up from bottom to top, the first point I encounter is right here at +1. And it's a bracket because it's closed. And again, it's going to keep on going to infinity. Now, in this case, when the domain is all real numbers, in order to figure out my increasing, decreasing, and constant, I need to split up that all real numbers. So for my increasing, decreasing, and constant, again, you don't see any horizontal lines. So the constant, again, is dne. So let me go ahead and erase here. So now, again, ignore the arrows. So this piece of the parabola looks like it's falling from left to right. So that side's decreasing. What we're going to see is when we hit that vertex of the parabola, that's when it changes direction. And then this is the increasing side. So again, we have to break up our all real numbers. So for the increasing interval for this parabola at 0 to infinity, and the decreasing is -infinity to 0. Try the next one. Again, let's evaluate the function. So I'm going to come over here and figure out where -3 is. It's right here. And then if I look up to get the y value, you can see it's at +1. And then come over here, see where 1 is for my x value, and it goes up to 1 as well. Now let's go ahead and figure out the domain, the range, the increasing, decreasing, constant. Okay, so for the domain, again, as we're walking across this x-axis, the first thing we encounter is right here at -5. And it's an open circle, so it's a parentheses. Then as I walk along, my next x value is right here at -3. It's a closed circle, so it's a bracket. Then I've got a little gap. I'll get you a second, Marcus. Union. And then as I keep walking, I've got an open circle on -1. And you can see as I keep going, it stops here at +1 with a bracket. Then I got a little gap. And then it starts up again at +3, open circle, so it's a parentheses. And again, this is going down and out. So down is -infinity, but out is going to be +infinity. So when I look at the x value, so the number that's in the parenthesis is my x. Let me see if I can erase some of this. So the x value, when x equals -3, which is right here, I come up to see where it's hitting the y-axis, and it's hitting it at 1. And then when I come over here and I see where x equals 1, which is right here, I got to see how high this point is, and it's also at 1. So the answers we're giving are the y values. The number in the parentheses is the x. So we're basically looking for the order pair where that number is. Again, we're going to walk bottom to top. So as I walk along here, going up to the top, first thing I'm encountering is this arrow. And it's pointing down to -infinity. And then the highest my graph gets as I walk up is going to be right up here over at the 3. And it's an open circle, so it's a parentheses. Now, it looks sort of like there was gaps here, but they weren't, because you got to look left to right. So I hit the arrow, but then if you look over here, then this takes over, and that's why there's no gap there, because it is all continuous, because it's x values, not y's. Y values, not x for the range. Now again, let's ignore the arrows, and let's see if we can figure out our increasing, decreasing. No constant still, no flat lines. So again, this line that's right here looks like it's falling from left to right, so this will be a decreasing piece. This one is rising from left to right, so it's increasing. Here, ignore the arrow, but this one, you could look at the arrow, but it's again falling from left to right, so it's also decreasing. So for the increasing interval, it's going to go from -1 to +1. For the decreasing, -5 to -3, and 3 to infinity. And again, remember, these are the x values. You're pulling increasing, decreasing, and constant from the domain. Yes? Question? Okay, no, the infinity should have a parentheses. Thank you. Let me fix that. There should be a parentheses. Infinity and -infinity always get parentheses. Thank you. Good catch. All right, next we're going to talk about even and odd functions and if it has symmetry. So when your function is an even function, what we're going to do is plug in a -x, and then if the negative goes away once we simplify everything, if it simplifies back to the original, then it's an even function. and it has it'll be symmetric to the y-axis. When it's an odd function, once you plug in negative x and then each term flips signs to opposite, then we're going to know that it's an odd function and it'll be symmetric to the origin. When it has x-axis symmetry, that's when y is going to be raised to an even power, or it's going to be an absolute value. So a function cannot have x-axis symmetry. Otherwise, it's not a function. So let's go ahead and try and see what I mean by this. So it wants to determine if the function is even, odd, or neither. So what I'm going to do to figure out what kind of function it is, I'm going to take all my x values and turn them negative. So I'm going to be plugging in f of negative x. So I'm going to make this a negative x, and I'm going to cube it, and then this becomes a negative x. So now once I simplify this down, if all of the signs are opposite of the original signs, then I'm going to say that this is an odd function. Okay? Because notice, originally this was positive, originally this was negative, so since both signs flip to opposite, it's an odd function, and it's symmetric to the origin. Let's try number 8. This is actually the graph of a parabola. Again, let's make all the x's opposites, make them all negative. And again, let's simplify it down. Whenever I square a negative number, it becomes positive. This went back to the original. So when it goes back to the original, then I know it's an even function, and the symmetry is going to be to the y-axis. So it's symmetric to y-axis. Because if you think about it, your graph of the parabola is going to be here, the vertex will be at 1, and it's going to look like this. And you can see that it's symmetric. If I folded that up, it would be symmetric to the y-axis. And let's try one where it's neither. So again, let's plug in opposite, or negative x. 5 times 3 to the negative x. This becomes 5 plus 3x. In order for it to change the signs, everything would need to be opposite. The only one that went opposite was the 3x, so this is neither. The 5 would have also had to have been negative. This has no symmetry. Let's try some more examples, and then we're done. Or then we have one more thing. Tell you what, I'm going to go ahead. Let's do 2 more examples, determining if the function is even, odd, or neither, and if it has symmetry. So again, to do this, we're going to make x negative. So negative x to the 4th minus negative x squared minus 1. Now we need to follow order of operations, so don't try to take care of that middle term and do key flip change. Do the exponent first. So again, remember, whenever a negative number is raised to an even power, it becomes positive. And now this is simplified, and notice this is the original again. So this tells me that it's an even function, and it's going to be symmetric to the y-axis. So it's got y-axis symmetry. Let's try this last one on this one, and then we'll move on to the next part, which is finding the zeros. So again, I'm going to plug in a negative x, 2, and plug in the negative x, and we're going to cube it. And again, raised to an odd power, this will become a negative x cubed. So we're going to make it negative 2x cubed minus 3x. And again, these are both opposite signs of what we started with. So when they're both opposite signs of what you start with, then it's an odd function, and it's symmetric to the origin. Okay, so here it says to find the zeros of the function. We've already done this. Whenever it says find zeros, find roots, find solutions, we're doing the same thing. All we're doing is setting our function equal to 0 and factoring it. So we've already done this. So I'm going to factor this. It'll factor into 2x minus 1 and x minus 1. Then I set each of the factors equal to 0. Add 1. 2x equals 1. Divide by 2. X equals 1/2. So my first answer is 1/2 comma 0. Add 1. X equals 1. And the other answer is 1 comma 0. And then I'm going to do the same thing on the last one. We've already done this. Plug in 0 for f of x. Solve for x. So I'm going to multiply both sides by x plus 5. This is just gone. So it's 0 equals 2x plus 5. So I'm going to subtract 5 from both sides. Negative 5 equals 2x. Divide by 2. And x equals negative 5 over 2. And again, written as a coordinate, negative 5 comma 0. So that is it. Again, when you want to find the zeros or the roots or the solutions, you are setting your function equal to 0.